Good morning children and welcome back to your chemistry class. So today we are going to deal with the more periodic properties. We have already finished most of them and today we shall begin with electronegativity. Okay, this one is left, so we wind up this periodic property today. What is electronegativity? It is the tendency of an atom to attract the shared pair of electrons in a covalent bond. Okay, so more the electronegativity difference, better will be the covalent bond formation, right? For example, if hydrogen combines with another hydrogen, now both these atoms, they have same electronegativity, means there is no electronegativity difference between the two. So what kind of a bond it is going to form? It is going to form non-polar covalent bond. Similarly, chlorine with another chlorine, what kind of a bond it is going to form? Non-polar covalent bond. Why? Because the electronegativity difference between the two atoms is zero or nearly negligible, right? But let's talk about HCl. What do we know over here? That hydrogen has a slight positive and chlorine has a slight negative charge. That also means that chlorine is more electronegative than hydrogen, or we may otherwise say that hydrogen is less electronegative than chlorine. Thus, over here, what are we going to see? A proper polar covalent bond will be formed over here with certain charges present on it, right? So, over what is electronegativity? It is a dimensionless quantity. Okay. Your electronegativity is a dimensionless quantity and it has no units. Fine. Now, before I begin to explain you more about electronegativity, let us understand what is the difference between electron gain enthalpy and electronegativity. Right? So, let me divide the page and here I write electron gain enthalpy. Okay, and here we talk about electronegativity. So first point about electron gain enthalpy, what did we study in the previous video? That it is the tendency of an isolated atom to attract the electron, right? So it is the tendency of an isolated atom to attract the electron. Whereas what is electronegativity? It is the tendency of an atom to attract the shared pair of electrons. Okay. Here it is the tendency of an atom in a combined state. Okay, in a combined state, that could be in a molecule, followed, to attract the shared pair of electron, right? Now, second point of difference between the two, this can be measured experimentally, this cannot be determined experimentally. So, can be measured experimentally. This is one point. This is cannot be determined experimentally. Clear? It is why it cannot be determined experimentally, because it is a relative number. It is a relative number. Okay. Let's come to the third point of difference between the two. That over here we know that electron gain enthalpy, it has unit, whereas electronegativity has no unit. So what is the unit of electron gain enthalpy? Has units. That is, it can be electron volt per atom, or it is what? Kilojoules per mole, right? Or it could be kilocalories per mole. Over here there is no unit. Electronegativity has no unit. Then what is the fourth point of difference between the two? This electron gain enthalpy is a constant quantity for a particular element, right? Whereas this is not a constant quantity for a particular element. It depends upon the factors like oxidation state or hybridized state, etc. So we can write over here that it is a constant quantity for a particular element, whereas electronegativity of an element is not constant. Okay, it depends upon oxidation state, hybridized state, etc. And the last point of difference between the two, that the periodicity of electron gain enthalpy is not regular, whether in period or in a group, whereas periodicity, it is regular in a period for electronegativity, but it is not regular in a group. So its periodicity is not regular either in a period, neither in a period nor in a group. Okay, whereas electronegativity, its periodicity is regular in a period, but not in a group. So I hope the difference between the two is very clear to you. What is the difference between electron gain enthalpy and what is electronegativity? Clear? Now let us discuss about the factors that affect electronegativity. Okay, so the factors could be, the first point, that is the size of an atom. What do we know? That smaller the atom, more attraction of the electrons will be there. Thus we can say that electron negativity is inversely proportional to what? Size. What did I say? Smaller the atom, more is the electronegativity. Okay. The second factor is the nuclear charge. The nuclear charge. That is, more the nuclear charge, more is the electronegativity. So we can say electronegativity is directly proportional to the nuclear charge. I hope these short terms you will be able to understand more. Oxidation state. Right? More the oxidation state, more is the electronegativity. So oxidation state is also directly proportional to electronegativity. So let us over here understand maybe the charges on the cation and the charges on the anion, and how do they show their electronegativity difference. So let's look at this Fe2 plus and Fe3 plus. Now let me know which one has more electronegativity. Now look here, Fe3, it will attract more electrons, right? Why? Because electronegativity is directly proportional to the charge, the nuclear charge. So when nuclear charge is more, plus 3 is here. So electronegativity is, remember, electronegativity is directly proportional to the positive charge on the cation. Okay, more the charge on cation, more is the electronegativity. So where is the charge more? Charge is here more, so Fe3 plus will be more electronegative than Fe2 plus. Okay, and I have also told you that with increase in oxidation state, the electronegativity also increases over here. Now that was in case of cation. Now let's talk in case of anion. I'm going to give you this N2 minus and N3 minus, and tell me which one is more electronegative. And over here we will see least electron repulsion. Okay, what are we going to see? Least repulsion of electron. Therefore, if there is least repulsion, that what it means, that is more attraction is there. More attraction is there, isn't it? So over here repulsion of electron will be there, but more than N minus. What about N3? The electrons, they will repel the most. They will repel the most. So more electron, less chance to attract the electrons. More the electrons, less chance to attract the electrons. Therefore, it will be less electronegative. Okay. So this is least electronegative. This is the most electronegative. So now look at the cations and the anion. More the charge, more. If a cation has more charge on it, it is more electronegative. If the anion has less charge on it, that is more electronegative. I hope this is very clear to you. Next we talk about fourth point is hybridization state. Hybridization state. Okay, so over here there are three hybridization states: sp, sp2 and sp3. So let us look at the percentage. This is, over here we find 50% S. Here the S is 33.33% and over here it is only 25%. So remember, the percentage of S is more, that means electronegativity is also more there. So where is S more? In sp. Therefore this is more electronegative. Sp hybridization state is more electronegative than sp2, and least is your sp3 hybridized. Followed? So are these factors clear to you? Now next we are going to talk about their trends. Then in a period, what do we know about period? Electronegativity will increase. Why? Because the nuclear charge is increasing. Nuclear charge increases, therefore electronegativity also increases. Clear? Then what about in a group? As we go down the group, the electronegativity will decrease. It will decrease. We all know that. Why? Because the tendency to lose electron increases, or ionization potential decreases, and electron affinity decreases, and therefore your electronegativity also decreases. Now let us talk about some exceptions. Okay, so some exceptions let us understand over here. Let me talk about period 1, period 2 and period 3. Now there are two scales that we have to study in electronegativity. One was Pauling and the other one was given by milliCALD. So over here Pauling scale I am going to give you first. So in period 1 we have hydrogen. Then period 2 you remember about carbon, nitrogen, oxygen, fluorine. The most highlighted ones only I am telling you. For period 3 we have phosphorus, sulfur and chlorine. And then we have iodine over here. So let us according to the Pauling scale, let me write down the value of the electronegativity over here. For hydrogen it is 2.1, for carbon it is 2.5, for nitrogen it is 3, for oxygen it is 3.5 and for fluorine it is 4. So what do you see over here? Let me finish this and then I'll ask you. Phosphorus is 2.1, sulfur is 2.5, chlorine is 3, iodine is 2.5. Okay. Fluorine, chlorine, bromine I forgot in between. Let me write down bromine also. Bromine and iodine. Bromine is 2.8 and iodine is 2.5. So just now I gave you what? Group. Down the group it will decrease. Down the group, can you see it is decreasing? 4, 3, 2.8, 2.5. Right? Then nuclear charge increases, electronegativity also increases. See 2.5, 3, 3.5, 4 and so on. So in a period it increases. Now what is the exception over here that I am going to tell you? So what you need to remember, if you remember the sequence it will be good. Fluorine, see it is 4. Okay. Oxygen is 3.5, 4, this is 3.5. Then we have nitrogen whose electronegativity is 3. Anybody else has electronegativity 3? Chlorine. See now over here nitrogen is also 3 and chlorine is also 3. This is the exception I was talking about. Bromine is how much then? 2.8. So here you can see the variation. 3 is here also and 3 in the group, and then we go down as 2.8. Okay, so this was a little exception that we find over here. Now, sometimes you don't have to learn the electronegativity values or the Pauling scale values, but sometimes here and there little bit you should remember. So I'm giving you a very easy clue to remember certain things. Like for example, for see iodine you have 2.5. Okay, for sulfur you have 2.5, for carbon you have 2.5. This is 2.5, 2.5, 2.5. Okay, then for phosphorus it is 2.1 and for hydrogen also it is 2.1. So these are some common ones which you can remember. Now how to remember? Look here, ISC, the class for which you are going to appear for your exam next time. Okay, so ISC they all have 2.5 electronegativity. Then look at this pH value, you remember? Both of them are going to have 2.1 electronegativity. So this is a very shortcut way of just learning handful of your electronegativities. Fluorine you already know, it should be 4, which is the highest, followed by chlorine. Is this clear? As we go down, but if you go to this nitrogen and chlorine, both of them have electronegativity 3. Now talking about scales, there are 2 types that we need to study. One is the Pauling scale and the other Mulliken scale. Okay, so let's talk about Pauling scale. So in Pauling scale we need to remember certain formulas. Okay, so if your unit in Pauling scale is given in for electronegativity is given in kilocalorie per mole, right, then the difference in the electronegativity of A and B will be equal to 0.208 under root the bond energy between AB minus under root the bond energy between AA into BB. Okay, this is the formula that you have to use. What is this? This is your electronegativity, and what did I say over here? This is your bond energy. Is that clear? So if your electronegativity is given in kilocalorie per mole, then this is the formula that you are going to use. But if it is given in kilojoules per mole, then the difference in the electronegativity of A and B will be calculated how? We will take the value as 0.102 under root the bond energy between AB minus, right, the bond energy between AA into bond energy between BB, right? So these are the 2 formulas that you need to remember for Pauling scale. Fine. For Mulliken scale, the electronegativity is the average of the ionization energy and the electron affinity. Okay, therefore over here the electronegativity will be equal to IE plus EA. IE means electron ionization energy plus electron affinity upon 2. And what will be the unit over here? Unit will be electron volt per atom or kilojoules per mole. Okay, so this is all what we need to study in electronegativity. I wind up over here. In next chemistry period, we will come to the last part of your classification of elements and periodicity in property.